Okay, so we're going to talk today. This will be objective 12. We are going to solve and graph inequalities, and we are also going to solve compound inequalities and absolute value inequalities. So solving and graphing linear inequalities in one variable should be a review from Algebra 1. So I've got a couple examples on that, and once I start talking about it, some of you are looking at me cross-eyed and going, huh, did we do this? Yes, you did it. Okay, so you'll remember it. And then compound inequalities, you may or may not have talked about it in Algebra 1. But I think you'll find it to be fairly simple as well. And then we're going to connect yesterday's lesson on absolute value equations to absolute value inequalities because they're very, very similar. Okay, any questions about that? Okay. Okay, so let's look at example 1. Explain to me the difference between an equation and an inequality. Okay, equation contains an equal sign, and the two amounts, it's a statement comparing two amounts that are equal. Okay, an inequality compares two amounts that are less than or greater. They're not equal. Inequality means not equal. And give me two amounts that are not equal. 4 and 5. Okay, so how would you compare them? You would say 4 is less than 5, or you would say 5 is greater than 4. Okay, that is what an inequality is. There is one rule that you need to remember when solving. Does anybody remember that one rule? Something about you got to flip the sign. I agree. When you multiply or divide by a negative, you've got to flip the greater than or less than sign. Everybody remember that rule? Okay. So here we go. You're going to solve this just like you solved an equation, except you got to remember that one rule. So step 1, parentheses. We are going to distribute. So this makes 24v minus 18 is less than or equal to 20v plus 6. So far, so good. Okay, step 2 is fractions. Ooh-ya, discussy, nasty, multiply by a common denominator. But we don't have any, so we're not going to do it. Okay, step 3, combine like terms. Normally, you combine what's on the left side, or you combine what's on the right side, but can we combine any like terms? No, not on the left side or the right side. Then step 4, put your variables on one side, put your numbers on the other. What do you want to move? 20v. I would go with my little tip to you to move the smallest variable or the one that is negative. What will that do? That will help keep your variable positive. And then what? You won't have to flip your sign. You know what I mean? Like if your variable is negative, how many of us might forget to flip our signs? Does that make sense? So try to keep your variable positive, then you won't have to worry about forgetting that little rule. So 24v minus 18 minus 20v. So that will make 4v minus 18 is less than or equal to 6. And then I'm going to move the 18 over and add 18. So 4v is less than or equal to 24. And when I divide by 4, v is less than or equal to 6. Okay, then we got to graph them. Okay, how do we graph inequalities in one variable? On a number line. How many marks is good to put on your number line? Anywhere from 6 to 10-ish, I would say, okay? 1 is not enough information, and you put like tick, 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 too many on there, then it's not easy to read. Graphs are meant to be easily read, okay? They're visual. So I'm going to put my number there. I do 3 to the right and 3 to the left. 7, 8, 9, 5, 4, 3. Open circle, closed circle on 6. Do we remember the difference between open and closed? If it is less than or greater than, it will be a clear or open circle. If it is greater than equal to or less than equal to, it will be a shaded in or closed circle. Okay, so this one will be closed because it's equal to. And then read from the variable, whatever we shade is what you could plug in for the variable. So V is less than or equal to 6. So which numbers are less than? So to the left. Left is less. So again, anything in the shade, pick me a number in the shade. 4. Plug it in, is 4 less than 6? Yes. Do you understand why we shaded in 6? You can plug that in because it's shaded. Is 6 less than or equal to 6? Yeah, it's equal to, so it works. Okay, any questions on that? You only have to flip your sign when you multiply or divide by a negative. So if I go back to this, what did I divide by? A positive 4. So you only have to flip your sign when you multiply. If I was dividing by negative 4 on both sides, then I would flip my sign. Okay, good question though. Good question. All right, so step number 1, parentheses. No. Step 2, fractions. Yes. Times everything by 5. So when I times this by 5, we get negative 15x. What do I get when I times that by 5? Very good. Don't forget, some people want to distribute that to the negative 4 and get negative 20 and distribute the 5 to the 22 and make 110, and that doesn't work. This 5 and this 5 will cancel out, and you only do it to this one fraction because it's all one term. Okay? And then from there, I'm going to move the negative 4 over and add 4x. And so you get negative 11. Then what are we going to do to both sides? Divide by negative 11. And if I'm dividing by a negative on both sides, then my sign will flip the other way. And I get negative 2. And with that, we'll go to lunch. All right, so we're picking up after lunch. We just solved this before lunch. And x came out to be what? Remind me. Not equal to. X came out to be greater than or equal to negative 2 because we had to flip our signs. Okay? So when we do our number line, negative 2, 3 to the right, and 3 to the left, what number would go here? Why negative 1? Why wouldn't you get larger and go like negative 3? Because negative 3 is not technically greater, right? It's, with negatives, you got to go backwards. So make sure you label your number lines correctly. All right, open circle, closed circle on negative 2. Closed, always read from the variable. Don't know why it has those lines on there. X is greater, and I still think alligator eats the bigger one. X is greater than negative 2, so which way would I shade? Very good, to the right. And you should always be able to check yourself, take a number that you have shaded and plug it in and make sure that it fits the bill. Like, let's plug in 0. Is 0 greater than negative 2? Yes. Any questions on solving a linear inequality in one variable? Good. Let's move on to compound inequalities. Go ahead and get this definition down first. A compound inequality are two inequalities joined by the word and or the word or. So let's discuss the difference between the word and the word or. Who can I pick on today? Jenna! That Jenna. Brianna said I could pick on you. Is that okay? All right, here we go. I'm not really picking. I'm just going to use you as an example. So if I look at Jenna and I say, Jenna, today, this afternoon, you have to go home and do your homework and feed the dog. What does she have to do? Do all of it. She has to do her homework and feed the dog. Right? Does everybody understand? If I look at Grace and I say, Grace, this afternoon, you have to go play your keyboard or watch TV, what does she have to do? One or the other. Okay? Okay. All right, so we're going to move on. So if I use the word and, stick with me on the analogy, please. If I stick with the word and, if you have to do this and this, then you are required to do both, okay? If I use the word or, it only has to satisfy one or the other, okay? You don't have to do both. So let's talk about it, how it works with inequalities. So I'll give you a second to write this down. First of all, do you understand that there are two inequality signs written up there? Yes. So if it's all together in one problem, would you think that it would be an and problem, that it would have to work for both if it's all together in one? Or would it be an or problem, that you could do one or the other? It's an and problem. So it will either say this inequality and this inequality, where your answer has to satisfy both inequalities, or if it's written all together within one, then you know that it's an and problem, that it's got to work for both. That y is connected to the left side and it's connected to the right side, so it's got to work for both. Okay? So the first thing that we're going to do is we're going to separate our inequalities. So you're going to start at the left side of your inequality. You're going to go all the way through the inequality sign, all the way till you get to the next inequality sign. And there would be your first inequality. So it would be 8 is less than 3y minus 7. And your second inequality, you just start on the opposite side and work all the way through the inequality sign, all the way till you get to the first inequality sign. And so it would say 3y minus 7 is less than or equal to 23. There would be your two inequalities. So I'm going to give you a second, and I'm going to let you go ahead and solve both of them for me. So I ended up with y is greater than 5 and y is less than or equal to 10. So we are going to have to graph these. Any questions on how I solved them? Give me a thumbs up if you got those answers. Okay. If all your hands are up, does that mean a question or does that mean you're good? Are we okay? Okay. All right, so we're going to graph these. So we got to put the 5 and the 10. So here's what I will tell you. On some graphs, on this one, I'll probably count by ones, okay? But if you have to go from, like, I don't know, -10 all the way to +20, would you want to count by ones? No. That's going to make your line go ridiculous. So you can count by other increments. Just make sure within that one problem, if you count the left side of your graph by 2's, you count all the way by 2's, all the way across the right side of your graph. Okay, so some examples you can count by ones, you can count by 2's, you can count by 3's, you can count by 4's. Remember, the goal is to get how many marks on your graph? Somewhere between 6 and 10-ish. Okay, if you got 5, that'd be all right. If you got 11, that'd be okay. But somewhere between 6 and 10. So I also will tell you that I like to, I don't necessarily like to start with 5 because I like to see numbers on both sides of what I'm referring to so that I know, whether I'm talking less than, greater than. So I would start with 4, 5, 6, 7, 8, 9, 10, and then I'm going to go one more and go 11 on the other side. 6, 7, 8, 9, 10, 11. Open circle, closed circle on 5. Open circle, closed circle on 10. Closed. And so here's the thing. Whatever I shade has to satisfy both inequalities because it's an and problem. I have to do both. So I want to know where can I shade that I can be greater than 5 and less than 10, less than or equal to 10 at the same time. I hear 6, 7, 8, 9, everything that is in between, right? So pick a number in the shade. Let's test it out. Let's make sure that I can plug it in for both. Give me a number. 6. Is 6 greater than 5? Is 6 less than or equal to 10? Yes. Okay. So you would not want to like shade up here, even though this is greater than 5 up here, right? But it's not less than 10. So it's got to work for both. So I'm going to let you try this one. Is this an and problem or is this an or problem? It's an and. How do you know it's an and? Because it's all together within one problem. So it is an and problem. But go ahead and separate it into two problems. All right, let me ask a question right here. Should I flip my sign because I'm going to get a -5 on this side? But I get a negative. I'm not dividing by a negative. I'm only dividing by +4, so just clarifying. So I end up with x is greater than or equal to -5. And I end up with x is less than or equal to 6. How many got that? Okay, so then I'm going to put it on a number line. What'd you count by? So as it gets a little bigger, I would count by like other stuff. Okay, anybody count by 2s? That's my girl on this problem. All right, so -6, -4, -2, 0, 2, 4, 6, 8. So -6. And if you, I mean, it'd be okay to do by 1s, but I'm guessing that you're, especially if you went one more, if you went all the way up to 7 and you started down at -6, then you probably had quite a few marks on your graph. So don't forget you can count by other things. So open circle, closed circle on -5. Closed. And -5's not on here. It's in the middle, so just estimate it. So closed circle here. Open circle, closed circle on 6. Closed. Where can we be greater than -5 and less than 6 at the same time? In the middle. And someone says, is it always in the middle? Yes or no? No, it's not always in the middle, but I will tell you this. You were just learning these, so I would say in Algebra 2, for most of the ones that we will look at, the and problems will be in the middle. Okay, but not always. Like, what if I said I want something that is greater than -5 and greater than 6 at the same time? So I shade everything? No, because that's not greater than 6. So everything that's greater than 6, right? If I shaded from here and above, that would satisfy that if it were greater, and that would satisfy that. So, but that doesn't get into until you get a little bit higher level math where it confuses you. Pretty much right now, everything that you will see that is an and problem will be shaded in between. Okay. So how do we know what kind of problem this is? Because it says or, yes. Generally, the or problems will say or, okay? The and problems will say and, or they will be written all together within one problem. So, do you need to separate them? No, they're already separated, so just solve them. What's the purpose of this problem? It's a fraction. So this would be the one time that I would say, I don't understand where 14/3 is, but what could I do? What would help me understand where to put it on the number line? If I made it a decimal, -10. K is less than -10. Sorry about that. So what is 14/3 as a decimal? So 4.6 repeating. Okay, now we're not going to plot in decimals. Okay, I would still plot using integers only. Integers and whole numbers only. So we want to go all the way from -10 all the way up to, like, where would 4.6 be? Between 4 and 5. Okay, so what do you want to count by? 5s, -15, -10, -5, 0. Yeah, we could do 5s. -15, -10, -5. Don't forget, I do like to do one on the far side of each number. 0, 5, 10. Okay, so -10 is an open circle. And where would 4.6 repeating be? Close to 5. So, and it's a closed circle. Okay. Wow. Okay. K is less than -10, so where would I shade? Where's less than -10? To the left. Okay. K is greater than 14/3 or 4.6 repeating. Where would greater than 4.6 repeating be? To the right. So explain to me how I can be less than -10. Give me a number that's less than -10 and less than 4.6 at the same time. -15 is not greater than this. I want less than -10 and greater than this at the same time. You can't, but we don't have to do both, right? It's an or problem. So I just want to make sure that what I've shaded satisfies at least one of them. So if I try -15, does -15 work for at least one of them? Which one does it work for? This one right here. Okay, so it works for this one. Everybody says, but it doesn't work for that one. It's okay. It doesn't have to. It's only got to work for one of them. You can do this or this. So it just has to work for one. And same thing here. These on the right side will work for K is greater than or equal to 14/3. It doesn't work for this, but that's okay. It only needs to work for one. Okay, so what do you notice about the OR problems? So the AND problems shade generally on the middle, and the OR problems generally, not always, but generally shade on the outsides. Okay? All right, so you try this one. What's negative 19 over 2? Make it a decimal, negative 9.5. So we need to go all the way from negative 9.5 all the way to 17. Okay, any questions about that? Thumbs up if you got it. Okay, good. All right, so what do we want to count by? Fives again, so negative 10, negative 5, 0, 5, 10, 15, 20. Any questions on making your fraction into a decimal and just estimating it between integers and whole numbers? 10, 15, 20. All right, open circle, close circle on 17. Open, and then open circle, close circle on negative 9.5. Is negative 9.5 closer to negative 10 or closer to negative 5? Closer to negative 10, right? So where is greater than 17? To the right. Where is less than negative 9.5? To the left. Does your shade have to work for both? No, as long as it works for one. Any questions about compound inequalities using and or? Solving two at one time. All right, good. Let's go to absolute value. Is it possible for it to satisfy both? It is, but I would say in Algebra 2, generally, just because you're first starting to learn these, most of the time the and problems will shade in between, and most of the time the or problems. But there's always, in math, you know, there's always those special examples that something different happens to. So it is possible. Okay. I mean, it's possible to even have a no solution where it doesn't work at all. Okay. All right. So this says the absolute value is less than 3. So here's what I'm here to tell you. It's very similar to what you did yesterday. So first of all, what would be the first step? To make sure that the absolute value is by itself. Is our absolute value by itself? Yes. Okay. So that's the first step. Second step is how many inequalities will you write? 2. There are 2 possible, well, there's multiple possible answers, but you'll set up 2 equations to get those answers. So, or 2 inequalities. So here's what we're going to do. You're going to take what you have on the inside and set it up to what it says. So the first one will say x is less than 3. The second one, we normally do what? Flip your sign, but here's what I'm here to tell you. If it's an inequality, guess what else you will do? You will flip your sign. So you will flip the 3 to a negative, but you will also flip the less than greater than sign as well. Okay? So this will become x is flip the sign here and flip the sign there. So you'll set up 2 equations, one to what it says, and the second one to the opposite sign and the opposite sign. The opposite greater than less than sign and the opposite of the positive or negative of the term it is. Okay? And someone said, Ms. Corns, why do you flip your sign? Well, that's what it means. That's what is going to help you when you plug your answer back in and check it. Now, I'm not going to make you graph all of these. I just wanted to make sure that you remembered how to graph. So I will make you graph like the basic linear inequalities or the compound inequalities, but the absolute value, I'm not going to make you graph them. But if you wanted to check, so let's think about this. And so I'll explain to you why you have to flip that sign and make it greater than. So give me a number that's less than 3, because that's what that says. 2. Okay, plug it in. Is the absolute value of 2 less than 3? Yes, that works. Give me a number that's greater than negative 3. Negative 2. 4. Give me something that's, well, positive 4 is, but how about let's just go negative 2 at this time. Okay, and then we'll get there why 4 won't work. Okay, let's go negative 2. Everybody agree negative 2 is greater than negative 3? Yes. Okay, plug it in. What's the absolute value of negative 2? 2 is 2 less than 3. Yes. Okay, so it makes it work when you plug back in. So if I were to graph this, so negative 3, negative 2, negative 1, 0, 1, 2, 3. Negative 2, negative 1, 0, 1, 2. All right, open circle here, open circle there. What's less than 3? To the left. What's greater than negative 3? To the right, so where would I shade? In between. So tell me, would this be an and problem or an or problem? An and problem. So here's why. Do you understand why 4 would not work? It's got to be, I agree, if I just said give me a number that's greater than negative 3 and you say 4. 4 is greater, but it's got to satisfy this as well. It's got to be greater than negative 3 and less than 3 at the same time. Okay? So I was kind of glad you actually said 4 so that we realized that. So anything in between in the shade, you could plug in the absolute value and it should work. Okay, does that make sense why you're going to have to flip your sign? Yes? Okay. So, 2 more. Step number 1. Is the absolute value isolated? Yes. Okay, if it wasn't, you'd have to isolate it first. Step number 2, we're going to set up how many inequalities? 2. Okay, so the first one, you set up to what it says. So how are we going to set up the first one? 6y minus 5 is greater than or equal to 13. Just what it says. The second one, you set up 6y minus 5 is what? Is less than or equal to negative 13. Make sure you flip your greater than or equal to sign and you make the 13 negative. So flip both signs. And then we're going to solve. So go ahead and solve. And again, you don't need to graph unless you just want to. It would be helpful like on a quiz or a test if you actually did graph it out. So let's just do this though. Let's pick a number that's greater than or equal to 3, greater than or equal to 3, but less than or less than, and this one is going to end up being an or problem, right? Because it's less than negative 1. So pick either or. Give me something not equal. I like actually greater. All right, so 4. If you plugged it in, what's 6 times 4? 24. And 24 minus 5 is 19. Is the absolute value of 19 greater than 13? Yes, that works. Give me a number that's less than negative 1.3. Repeating. Negative 2, right? All right, let's plug in negative 2. 6 times negative 2. Negative 12. Negative 12 minus 5. What's the absolute value of negative 17? Positive 17, so it doesn't work. Yes, so in this case, this would be an or problem, okay? Does that make sense? Because it's going to be shading on the outsides. It would be greater than 3, or you could pick less than this, and it would work. Okay? Taylor? No, you don't. You don't. Okay? All right, last one. And then we'll be done for the day. I'm just talking about if you shaded it, it would be on the outsides. So I ended up with x is greater than or equal to 3, and x is less than or equal to negative 19/5. Okay, a good way to check it is to pick a number for both. Pick a number that's greater than 3. Okay, and I wouldn't pick 3. Why wouldn't you pick 3? What if the answer was x is less than or equal to 3? Like, what if you messed up your sign, the greater than less than sign? Does that make sense? If you just picked 3 and made it equal, it wouldn't test the whole greater than less than issue. Does that make sense? So I like to pick a number that's actually greater or actually less, so that you know if you actually solved it correctly. Any questions about that? And then you could plug it back in and test it out. Where do careless errors happen? I see people who forget to set up 2 equations, first of all. They just set up 1. And then they forget to, they might flip like the negative 17, but they might forget to flip the less than greater than sign. Okay, just remember to flip both. Rhea, question.
So, like, the second problem you, like, write down, right? And you switch up signs. What if you, like, divide by a negative, so then you flip it again?
Yep. Very good question. What if you set it up and you flipped your sign, but then you have to, in the middle of your problem, divide by a negative? Do you flip the sign back? Yes, you do. Okay, and we'll try to look at some of those next week as we do. Okay? All right, so no homework. Enjoy your weekend. You're the